Ever wonder why you, your dog, and everything else aren't floating away? What keeps the moon circling Earth instead of drifting off? The answer is gravity, an invisible force that holds galaxies together, keeps planets in orbit, and makes sure your popcorn lands in the bowl. Gravity is everywhere. Everything with mass pulls on everything else. The bigger the mass, the stronger the pull. That's why we stick to Earth. Our planet's mass is huge compared to ours. Even you have gravity, but Earth's is much stronger. Think of an apple falling from a tree. That's gravity in action, the same force that keeps the moon in orbit. Gravity gives us weight, lets us play catch, and keeps planets from drifting into space. But here's the wild part. After centuries of study, we still don't fully understand gravity works. We know what it does, but the deep-down reason remains a mystery. Let's dive into the story of gravity, one of science's coolest adventures. In the 17th century, Isaac Newton wondered if the force pulling apples down also reached the moon. He realized gravity depends on mass and distance. More mass means more pull, and the farther apart objects are, the weaker the force. Newton's law of gravitation could predict the strength of gravity between any two objects, from bowling balls to planets. His formula explained orbits, tides, and cannonballs, giving us a cosmic rulebook. But Newton didn't know gravity worked. He could describe it, but not explain its true nature. How could the sun pull on Earth across empty space? Newton admitted he had no clue. That mystery would wait for a new kind of genius. Enter Albert Einstein, who wasn't satisfied with gravity as a mysterious force. He proposed that gravity isn't a force at all, but the result of mass-curving spacetime, a four-dimensional fabric. Imagine space as a giant trampoline. A heavy object creates a dip, and smaller objects roll toward it, not because they're pulled, but because they follow the curve. The Earth orbits the Sun by following the curve in space-time the Sun creates. For Einstein, space and time are dynamic, shaped by mass and energy. Mass tells space-time how to curve, and curved space-time tells mass how to move. This idea explained everything Newton's laws did, and more. Einstein's theory made new predictions, setting the stage for a scientific showdown. The universe, it turned out, was far stranger than Newton ever imagined. Now it was time to put Einstein's vision to the test. Einstein's theory needed proof. If gravity curves space-time, even light should bend as it passes massive objects. In 1919, during a solar eclipse, astronomers photographed stars near the sun and compared their positions to when the sun wasn't there. If Einstein was right, the sun's gravity would bend starlight, making stars appear shifted. The results matched Einstein's predictions exactly. The starlight had bent. Headlines declared Einstein a genius, and our view of the universe changed forever. Since then, general relativity has passed every test, from GPS satellites to the detection of gravitational waves. Einstein's curvy universe is now the foundation of modern physics. Gravity isn't just a force, it's the shape of reality itself, but the story doesn't end there. Einstein's theory rules the world of big things: planets, stars, black holes. But on the tiniest scales, quantum mechanics takes over, describing a jittery, unpredictable universe. The problem? General relativity and quantum mechanics don't fit together. When we try to use both at once, like inside black holes or at the Big Bang, the math falls apart. Physicists are searching for a theory of quantum gravity, hoping to unite the big and the small. Some think gravity has a particle, the graviton, but we've never detected it. Others explore ideas like string theory, where all particles are tiny vibrating strings, and one vibration could be the graviton. It's a wild frontier, and we're still searching for answers. Gravity, it turns out, gets really weird at the edges of what we know. The quest continues. Our journey began with a falling apple and led us through Newton, Einstein, and the mysteries of the quantum world. Gravity transformed from a simple force to the very shape of the universe. Yet, the biggest questions remain. Why does mass curve space-time? What is gravity at its most fundamental level? Scientists are pushing boundaries, exploring extra dimensions and new theories. The search for quantum gravity is the next great adventure. Every time you drop your keys, you're witnessing a cosmic mystery. The story of gravity is the story of our quest to understand the universe and ourselves, and the next chapter is just beginning.